Manager and pre-sales engineer for the security group. Today we'll be covering IP network and storage for security surveillance design and practices made simple. Wow, that was a mouthful. Before I do start, we cannot hear any questions verbally that you may ask. What we ask is during the slides, anytime throughout the session, please use the control panel and type in a question. I have a co-host and wingman, Ted, who will be watching for questions and will interrupt when appropriate to ask me, and I'll try my best to answer them per screen. I might defer to a different screen, or I might hold it till the end. We'll also have a question session at the end. One of the other things that I ask is at the end of the webinar, when you're signing off, there's a very brief questionnaire. Please fill that out. We use that information for feedback to improve the webinars as we go along. We found that your input has made a big difference in how we present and what we present. So let's get going here. We'll try to get going here. Okay, during this webinar, it should take between 25 and 35 minutes, including questions. We'll cover calculating camera bandwidth, camera storage requirements, sizing NVRs or video recording servers, calculating IPC and bandwidth requirements, and correctly distributing camera video. Now, I realize for a lot of our audience, this will be, some of it will be review, some of it will be new, and we're taking a little different approach here. We're just going to break down a soup to nuts from beginning to end with 10 simple rules that you should follow in every configuration or proposal that comes your way. Okay, first, what is camera bandwidth? Bandwidth is strictly defined as a quantity of data or a certain amount of video that can be transmitted, meaning it's a specification, or is actually transmitted in a specific amount of time. For instance, if we're talking about how much or what is the capability of a pipe or a camera, then we would rate that as 1 GBE, 1 gigabit per second, or 56 megabits per second. That would be the maximum capability. If your camera is actually running, it would be putting out data at a certain rate, 22 megabits per second, 7 megabits per second. The general measurement for bandwidth on the LAN and camera side is in bits per second, or kilobits per second. Okay. There are a lot of things that actually affect camera network. Most specifically are the cameras themselves. Your camera resolution. The higher the resolution, the more data is being collected and sent down the IP network to be recorded. So very simply, a 640 by 480 VGA image does not send as much data as a 5 megapixel camera does. Okay. The type of compression method, there are basically 3 different standards that are used today. The first is no compression at all, just a raw streaming data. Obviously, the largest amount of data that has to be transmitted. The more data, the more time. You can reduce your time by having higher speed pipes, but the reality is cameras are connecting to 100 megabit networks. MJPEG is the earliest, and it's the simplest compression algorithm. It is the least effective of all of the compression methods. Middle of the road, oh my gosh, I have a typo, is MPEG, not MJPEG again. Again, it offers better compression than MJPEG, and at the top of today's standards list is H.264. Along with the compression method is the quality of compression. The more you compress the data, the more the less space you're using, obviously, but you also lose quality as you compress more. So high quality settings for compression uses more space, and a lower quality setting on your compression settings will use less space, but you'll also have a lossy picture. Image complexity. Who drew these pictures? They're wonderful. Obviously, the amount of data that a camera is capturing combined with the compression algorithms greatly affects how much data you have. If you're compressing just purely black and white data, you don't have as much information to move as you do moving color. And the more objects, the more colors, the more things that you have within the field of view of the camera, also it makes it more complex, and consequently there's more data transferred. Percent of motion. Now with MJPEG compression, this is not a factor because it's essentially taking a picture. It's a static image per field and compressing it. But with MPEG and H.264, both of which are motion-based in a video sense, not a picture sense, the higher the amount of motion that's within the field of view, the more data is translated. And this is an example of very simple motion back and forth, less data, more complex, more motion within field of vision. Much more data is being transmitted out. Okay. Frames per second. How fast, how many frames are you transmitting in a particular, in a second? The more frames the more information you're obviously transmitting. Okay. Now, all of the above, resolution, compression method, quality of compression, complexity, motion, and frames per second, that determines a camera's bit rate. And in a lot of camera calculators, that's strictly the field that's used. You could mathematically take the bit rate and come up with how much space is required, or how much capacity or how much data you're going to move to the NVR, and then subsequently the storage.
Dick, I got a question.
Yes.
I'm sorry, I got a question just came up. Going back to your fabulous drawings, some of the rate calculators don't account for image complexity or percent of motion. How do you account for that when you're trying to calculate?
Okay. What happens is, in a lot of rate calculators, they take a baseline approach to image complexity or percent of motion, and they factor in a 50% or a percent of motion on average. If you were to measure the screen, within a quantitative grid scale, they'll use a default value of 30% as a base factor. You will see some calculators, in fact the one that we use regularly, do take that into account, particularly because it does affect, and I'll be able to show you later, it does affect how much data in your base bit rate significantly. That's one of the things that you have to ask. You can't take a lot of tools that are available verbatim and write your entire spec around it. If you're concerned about a parking lot field of vision versus a busy office setting or a busy intersection that you're monitoring, you might want to look at a different calculator, or you might want to ask the software manufacturer for specific help in making adjustments to the values that they're presetting within their calculators. And last, your bit rate per camera times the number of cameras is going to equal the total amount of bandwidth that your camera LAN is going to require to move data correctly to the NVR. Okay, correctly sizing camera bandwidth requirements. Okay, here's our first rule. Plan your camera bandwidth around peak, not normal operations. The first example, I have a sample under normal conditions given these X parameters. We have a total throughput of 307.2 megabits per second. And this is just assuming a normal daily sequence. However, you have to realize there are going to be times in the day where things are more busy. If you're monitoring, for instance, the front door of a school right before the school bell rings, you're going to have, the images are going to be much more complex. There's going to be a much higher percentage of motion within the field of view. So what you see in normal operations, if you're looking with people coming in and out, would represent 307.2 megabits per second combined across all of these cameras. However, at peak instances, you can see I've driven up image complexity and percent of motion, and the net result is we almost triple the amount of data that's coming across at any one time. Now, if you want to adequately capture these sequence times, you always want to plan your camera network around peak times or maximum percentages being presented to your storage. Otherwise, you're going to get frame drops and you're going to lose a certain amount of imagery that may be critical upon review. Rule number 2. Never exceed 75% of a switch's output bandwidth. And the reason for this is within a LAN or a network that's using an internet protocol, such as ours with cameras, talking to the NVRs, camera data is not the only thing that's moving back and forth across the network. There's protocol overhead. There are in fact collisions where 2 sets of cameras, 3 sets of cameras, 5 sets of cameras are all trying to send data at the same time. And part of the protocol that is, it says, I got a bunch of you guys and you just hit me at the same time, so I'm going to retime and restart my sequence. And what it does is it then allows one camera to put in data with a preset time, and the next one would come in and the next one would come in. So in order to facilitate collisions and handshaking back and forth and so forth, a lot of bandwidth is taken up. So always err on a conservative side. I've actually seen some places they say 60% of the bandwidth. As a general statement, though, held to within the IT community and the surveillance community, 75% is a good number. So if the output of your switch is 1 gig, you should never, the total aggregate of all of your cameras should never exceed 75% of the total bandwidth, so 750 megabits per second rather than 1,000 megabits per second. Okay. The next thing that's always overlooked, and I've seen this in virtually every single situation that I've been involved in. Everybody is very recording-centric in this business. They want to make sure that, you know, there's enough bandwidth to record. However, one of the things that affects your recording bandwidth is how many of these cameras are you monitoring? What video are you looking at that's already been recorded? Where does it come through the network and how does it affect it? If in certain circumstances, if you're recording 480 cameras and you have a value of 1, just a set of value of 1, and then you monitor half of those cameras, you've actually added another 50% of available LAN bandwidth to monitor with. So when you do your calculations, take care of your recording requirements, then examine what your monitoring requirements are. If you've just got the one desk at the front and the desk at the central monitor station and they're rotating through cameras, this is a minimal impact. but in more and more of these situations that we're coming across, they have 200 cameras, and at any one time they have 50 of the cameras on display on video walls. So in that particular case, you've added a significant amount of bandwidth usage. So always take your monitoring bandwidth totals, your recording bandwidth, add them together, and apply the 75% rule.
Okay, Dick, I have a question.
Yeah.
Why can't I use 100% of my 1 gig link bandwidth?
Okay. Just as I kind of touched on a little bit before, there's more happening on that LAN than just video, monitoring or recording video. There's a transport that's being used. It's just not streams of data. There's actually a protocol called the Internet Protocol with the sub-protocol called the Trivial File Transfer Protocol that ride in there, and they do handshaking back and forth. I have video for you. Are you ready? Yes, I'm ready to take the video. Here it comes. Now you get your video stream. Then there's acknowledgement back that I got the video. I'm fine. So that handshaking back and forth takes up a certain amount of the bandwidth. And then there's also the fact that the 1 gig and 100 megabit protocols, they don't go out and say, is somebody available? They do that, plus they do this. So imagine you have 5 cameras and they're all looking at the line and they don't see any traffic. So what do? All 5 of them at the same time start to transmit their data. What results is a collision, right? So we had 5 people. It's kind of like when you're at a 4-way stop and then everybody starts to go at the same time, right? You're going to get an accident. You're going to get collisions. So the protocol is built in to say, okay, we tried the nice way of checking if the line's empty. Now let's go back and let's accommodate those 5 cameras when they all send their stuff out. We're going to call it a collision, and we're going to reset timers, and we're going to give time for the different cameras to get their data through. So you eat up a significant amount of that 1,000 megabits. You're going to eat up, 200, 250, maybe only 150, but good rule of thumb. Reserve 25% of your bandwidth for protocol collisions and other miscellaneous. Okay, I talked a little bit about it. I thought I'd show you a graphic. Sometimes monitoring cameras or reading data does not affect your bandwidth. Remember, you always want to be very protective of your recording video streams. You always want those to go through best case and get recorded. And sometimes monitoring does or doesn't affect it. If you can see the blue link in the middle of your screen, let's see if I can get a better pointer here. Well, okay. Let's just leave the pointer alone. In the middle, you'll see a blue link through a separate switch. If you have dual feed cameras, you can split your video out through a completely separate network. And that completely separate network now does not impact your video recording stream at all. I have thrown in a PC, but that can just as easily be a management server, client management viewing server, or a number of individual clients that are viewing. So the blue line, no effect, no foul, no harm. However, if you look at the orange screen, I have to route the data through the same switch using the same camera feeds, and it is going to affect the bandwidth of the switch and its ability to process data through. So it does have impact. If there's 2 different other ways besides direct viewing, you can view video directly from the NVR live. You can review data that's been recorded. That would be depicted in the red line. And most definitely, the red line affects a number of things. Camera bandwidth, because you're using the camera switch to retrieve data. You're affecting the bandwidth of the NIC cards on the camera side in order to retrieve the data, which is also shared with the cameras. And you're also, if you're viewing stored data, you're also impacting bandwidth between the NVR and the actual storage. So you need to be cognizant at what level and what things you're looking at any one time and how they'll affect the ability of your entire subsystem to record data. Rule number 4, plan your camera storage capacity around normal operations. Now this is in conflict with bandwidth provisioning. Remember when I said plan your camera bandwidth around peak operations. You always want to be able to capture peak data episodes within your surveillance area. However, those will always represent a smaller percentage, and a small enough percentage, that it's not going to greatly affect how much storage you have. So it's just a lot easier to work around your normal day-to-day operations of anticipated traffic and triggering and so forth when you calculate your actual storage capacity that you're going to need. Normal operations should always include cyclic increases in video traffic, and I don't mean short spurts of time. I mean work hours versus second shift versus being closed the balance of the night, say from midnight till 6 o'clock in the morning. Also remember, capacity that you're calculating is usable capacity. That's how much storage you need on the disk to be available for your surveillance application, okay? Not raw capacity, not how many disks times the capacity. When you're implementing RAID 5 and RAID 6 protection levels, they consume a certain portion of the available space. So if you come to me and you say, I need 8 terabytes of data, I know that if you're going to do RAID 5 or RAID 6, I'm going to have to add in extra drives. So if you say 8 terabytes, I'm immediately going to say they need 8 1-terabyte drives, plus they need another 1 terabyte drive to enable RAID 5 protection. Or I know I'll need 8 1-terabyte drives, plus 2 more 1-terabyte drives to enable RAID 6 levels of data protection. So that's one of the services that we provide, as do much of our competition, as well as the actual manufacturers. We can all help you calculate that. Not only that, when you become intimate with more complex storage arrays, it's not just RAID 5, it's RAID 5 on this shelf, RAID 5 on another shelf, RAID 5 on another shelf. So there's an aggregation of additional storage that's required. But when you talk, whenever you don't talk RAID 6 capacity, always be clear that this is the amount of capacity or storage I need. And you'll say, does that include RAID 5? And you go, no, it does not. Right? I have 2 examples. Example 1 shows a configuration where they took into account an overall picture of what they would require in terms of storage. I have 3 different camera sets. I'm running at H.264, average quality, average image complexity, average motion. I'm running a pretty high FPS, and I'm retaining data for 30 days. So if this was a normal operation at their site and I'm recording 24 hours a day, I'd need 64.1 terabytes of data. You can always fine-tune it and work in business hours or work in after-hours inactivity. So in the second example, I took the same cameras and I left in the same complexity and percent of motion, but what I did do is I modified recording percentage, which is how many hours in a day. So if you look at the first line, I have a 1.3 megapixel camera, and I adjusted it for 22 days of data retention, and I limited it to 12 hours of recording, say a 6 to 6 or a 7 to 7 scenario in a typical office. However, I made an allowance in a 30-day period for the weekends, 8 days, and I have a much lower percentage of recording. And this is actually a pretty hefty recording thing where I'm making allowances for someone to come to the front door. You know, it's a bad record on motion type of thing. But what has happened is the net is by adjusting recording hours and days of the month, I've reduced my capacity from 64.1 terabytes to 50.3 terabytes. Right? There are other assumptions and other calculations that you certainly need to add in. I just wanted to make a demonstration. Settings for record on motion. I did lower my FPS during the weekends. You might want to drive that lower. Your percent of motion is going to be much lower. You can lower those numbers. So you can take different camera calculators and get a pretty good idea of what your capacity requirements are going to be for storage. All right, rule number 5. Always check with the software manufacturer for disk performance and application capacity requirements. And this is really important. Different applications that are out there have different performance requirements at different levels. Some of the more sophisticated products out there are using complex SQL database operations. So they take a video stream in, they move it to the side, they break it up, they tag it with a lot more information, and then they send that data out with informational data as well as the video in a proprietary format. Now, all of that data manipulation requires high-speed disks. It has to be done. It has to keep up with the video stream that's coming in. So the way that they do that is they apply a little more CPU horsepower. They require higher speed 15K RPM disk drives in order to get it in, massage it, add it, tickle it, and then move it out to the and get it to the storage. So they use the speed of the storage to make up time. Other applications just take the data as it comes in an H.264 format, put timestamps on it, camera stamps on it, and feed it out the back. They don't have as high a performance requirement as a more sophisticated database application does. So it's important that you look at what their performance requirements are for the disks, and then we would help you configure the system correctly. Another thing that impacts, and it's a little off of the actual storage of the video, is analytics and management servers. If management and analytics is built into the same server, the same NVR, you're going to have higher performance disk requirements. You're also going to impact CPU operations. Right? Rule number 6, allow for the unexpected. Give yourself some breathing room. I find this is a problem for myself all the time. I do all the calculations and it comes up and it says it's 7.9 terabytes. And I know that my storage subsystem can give you 8 terabytes. In a lot of cases, if it means that I have to add another shelf, that would add to the expense, and I'll hedge on it, and I'll make a notation and say you're really close on the storage requirement versus what I gave you. Do you want to look at it with more? If it just means adding another disk, which is pretty insignificant within the cost structure of the whole solution, I'll just add the extra disk. I'll build in that extra 10% just to give you a little bit of breathing room. Rule number 7, don't take the surveillance software manufacturer's hardware calculators to the bank. Earlier we mentioned, I had the question, hey, I don't have an image complexity setting. I don't have a percentage of motion setting, right? These are examples where they take presets. Sometimes the preset airs on the high side, which is good. Sometimes it's on the low side. Sometimes they pick on the camera calculators a very, very low bit rate that is absolutely ridiculous. It would be the equivalent to low quality all the time. So understand the information that they're giving you and balance it against common sense and vendors to help you understand, could there be a shift that you need to make, okay? And that's why I say guidance is provided for and should always be minimally followed, meaning take what they say as a minimum and then justify that number as being correct or expand as required. They're going to give you maximum camera supported per recording server. They're going to tell you what type of CPU and how many CPUs and how much memory. They're going to give you storage capacity for the video. But I've seen a lot of the calculators forget to accommodate how much space do you need for the operating system and their application. If you're on that bubble at 7.5 terabytes, that could be the amount that puts you over where you'll actually come up short. Things to call into question. If you ran analytics, and a lot of packages are out there, they have the analytics option, but it's not part of their hardware support calculators, right? How much will the CPU and disk I/O be impacted? Will more memory be required to support the analytics? If I'm running analytics, does that impact how many cameras you said I could use? You might start out with 64 cameras, but if you run the analytics package, realistically you might have to chop the number of cameras per NVR in half, right? And again, keep coming back to this rule. When the system's installed, monitor the CPU memory. Make sure that you're not sitting there consistently running at 75% of memory, 75% of CPU capability. At 75%, any peaks can put you over. There's not a lot of breathing room there. Feel more comfortable with the 60% or below number, and even then you're pushing it.
Okay, we have a question, Dick.
Yeah.
You mentioned the 75% thing again. Why would I waste 25% of my capacity?
You're not really wasting 75% of your capacity. At any one time, there's a whole bunch of things happening. Now we're moving away from network LAN explanations about collisions and retiming and protocol. Now we're going to move into a system arena, and there's a lot of things that are happening there. For instance, when you look at percentage of memory used, some of that's for application, some of that's for operating system, some of that is for page filing, where you're buffering data before it goes out to storage. So there are a lot of different situations where you want to have that extra reserve. Something happened. The I/O system got caught up doing something. It received a couple of error notifications. It started failover, and it's now running in degraded mode. Consequently, you're going to have to use more memory to buffer the images up before you send it out to the storage. Okay, that's all of a sudden you're going to use a little bit more memory than you thought that you were before. Normally when you get a backup on page file, you get a little bit of a backup on the memory. The application goes into a mode where it starts to use memory resources. So and then there's peaks when you're running along, and you got that. Remember, when your camera's going to peak mode, you got that 15 minutes when all the kids are rushing to the door to get into the school on time before the bell rings. That's going to represent an additional peak load on your CPU beyond the normal operations. So always, whenever you can, accommodate peak times. If you don't, the nicer applications, they keep on going and they say, yeah, you lost some data. Some of the other ones say, I'm out of resource, and they start logging system errors. Some of them react as poorly as bombing out. Right? So when they run out of resource, they don't flag you and compensate. They just go fix the problem. Right? So build in some overhead. Whatever happens on the camera side is going to affect the NVR. And whatever happens on the NVR is going to affect your storage.
I have another question in relation to that subject. How does a particular video impact the processor?
Depends on what it is and who's doing the work. Cycling through, for instance, there's an obligation on the NVR's part, processor, the memory, its total resources to process through within a certain amount of time any data that comes through. So in order to do things faster, it requires more CPU time, as well as typically memory resource and so forth. So the more load that you give it requires more CPU power. For instance, if you were to take 32 cameras and they were all running at a baseline setting that you decided was perfectly safe, and the reality is along the way it isn't running that way. There's a lot more data coming out of the cameras than you anticipated. Field of vision was more complex. There was a lot more motion and everything else. Whenever you would get these burst areas, while you had a baseline of 32 cameras, it could effectively, for short periods of time, as mentioned before, pumping out the equivalent of 48 cameras worth of data at any one time. That requires more power. Remember, your NVRs are built to handle X number of load. Some people base it on FPS. Some people base what CPU power or how many NVRs you need based on bandwidth from the cameras. There's different breakpoints, but they all come down to the same thing. How many cameras or what quantum of data can this product support? And if your cameras vary, so does your CPU load.
Okay, we're good. Thank you.
Alrighty. Okay, there's two sides to every NVR. I thought that was funny. I know you guys don't. Basically, what we've done, we've taken the NVR and we've handled the upper camera side, and now we're going to look a little bit more on the bottom half or the back side, the IP SAN storage. One of the things I should have prefaced this whole demonstration around is it's built around the fact that you're using IP SAN storage versus direct attached storage. A lot of the same rules apply, but they're more specifically addressed with IP SAN because it's a broken out module instead of being held internally. Okay, IP SAN storage requirements. You got to make the shift. Cameras talk megabits and storage talks megabytes. Small b, big B. One generally within bandwidth and megabytes as with regard to actual storage. One of the things that has to be understood is when the camera data goes into an NVR, what comes out of the NVR to go to storage is more. Now, depending on the application, how much more, if it's a simple exchange of data, bring the stream of data in, put a small tag on it, move it out, it's not a lot more, but it's more. And the more data you have coming out, the more time it's going to take to write it. Or you're going to have a higher bandwidth and you're going to have to write it faster. There's no other way to do this, all right? So I wanted to make sure that this relationship of data in does not necessarily equal data out. The other thing is if you talk with an engineer, and we'll take a simplest method is take an H.264 stream in and you pump it out the backside. You say, well, what's the bandwidth difference between the two? And they go, they're identical. And you say, so if it took 2 seconds to go into the NVR, it took 2 seconds to come out of the NVR. And they go, yes, it does. Now, here's the reality. That can't happen. Because a stream of data coming in from a camera, while it has protocol restrictions and everything else, it comes in, the NVR now has to look at it, determine timestamps, camera information, and create even a small amount of extra data. And at the same time, it has to move it from a video stream into a block of data, which means you come in, you got to fill up the block. Now the block and the extra information comes out. What that means is it came in at one speed, it came out at a different speed. It's going to come out using more bandwidth than it did coming in. So you need to understand you can't always use the camera bandwidth number as a direct correlation to your storage bandwidth requirements. So you'll see on a lot of the manufacturers' camera things, you'll see a difference between the bandwidth the cameras use. Even if you divide it by 8 and you see megabytes per second, you'll notice that that number is higher. Always use the storage bandwidth number when trying to calculate how much iSCSI bandwidth you need. Okay, rule number 8, check with the software company for total megabytes in versus out. Rule number 9, total NVR bandwidth out should never exceed the Dick Cicchini standard, okay, it's really an industry standard, of 75%. Here I have several NVRs, and I've depicted very high end here. I've got 64 5-megapixel cameras with a camera bandwidth requirement of 865 megabits per second. I made it very simple. I carried 865 megabits per second on the outbound side. I had a requirement of 460 megabits per second to go into my storage. That was the total aggregate, taking all 4 of the systems and going through. In this drawing, you'll notice between the switch and the storage, I have 5 lines. I have 5 1 gigabit ports. So I meet the 75% rule for being able to handle the traffic from all 4 of those NVRs and all of those cameras into my storage. But I had to use 5 1 gig ports. Okay. Now, let's tag in another 4 NVRs with 4 sets of 64 cameras running at 5 megapixels. At this point, I've exceeded the ability of 5,000 gigabits per second. I've also exceeded the maximum number of trunks or ports that I can have come out of this particular iSCSI product, iSCSI storage product. So what had to happen here was we had to rethink the infrastructure. Everything can stay the same at the VME level, but I had to replace the switch with a 10 gig switch so that I could get a 10 gig pipe between all of the NVRs and the actual storage to accommodate that level of bandwidth that was coming through the system. Okay. Now, we're not dealing today with product specifics or high availability, but I do want to make a special note. What you're looking at now is a single controller product. Our HA products are modularly broken out into multiple controllers, 2 controllers, and when they're running in dual controller mode, they have double the bandwidth, and they're in an active failover mode. So if you lose one, the other one takes over. If you lose a switch, the other one takes over. But when you're planning for bandwidth, always plan for worst case. And worst case would be I lost one of my iSCSI controllers. I'm running in failover mode. So plan your bandwidth requirements. How many 1 gig ports do I need? How many 10 gig ports do I need? Plan them as if you had a single controller instead of a dual controller. That way you're guaranteeing that you're not going to have frame drops, you're always going to get your data, you're always going to feed your data out. And my last rule, rule number 10, balance camera output. Very quickly.
Sorry, Dick, I had a question on the last slide that just came in. What do you mean by the output bandwidth? Can you be a little more specific on that?
Okay. When there's a difference between, and I kind of glossed over it, I was a little bit lazy here. If we go back a few slides, I kiddingly said there's 2 halves to an NVR. Right? There's the front side, the camera side of the NVR, and it's got its own separate DIC ports going to a camera LAN, and it has its bandwidth requirements that have to be made and met. Then we talked a little bit about what camera feeds going into a system does not equal what comes out of the system in terms of storage. So when I say the output of the NVRs equals the input to the storage. Always calculate based on the output of the NVRs. What's the total bandwidth? I'm trying to find my cursor, guys. If you look at the, here it is. Let me see here. Okay. If you look at this area here, these are NVRs. So when I say output, what is the output from each of these products, each of these NVRs, added all together? That's your total output, because all of these are going to come out into before. Let me go back one picture. Okay. In this case, I have my output coming in, and I'm using 5 1 gig ports, and I'm more than adequate to meet my bandwidth requirements. So output of the NVRs should be less than the input into the storage. Here, I've now doubled the output by virtue of adding double the number of NVRs and cameras. I would have exceeded the 5 individual 1 gig port capability. So I was forced to make sure that the input to my storage was greater than the total output of all of the NVRs. Does that make sense? Okay. Rule number 10, we're back to rule number 10. Balance camera output across multiple iSCSI volumes. When you write data and you're setting up your IP cameras, you're all familiar with this. You take the camera and you say, I want you to write it to drive D and call it file PDQ, camera 1. And camera 2, I want you to write to drive D in this folder, and I want you to call it camera 2. Right, I'm simplifying the names. And it's very easy in a lower camera count environment just to write to a single drive. It's easy, it's clean, and it makes sense. But as your capacities and your number of cameras start to go up, you want to play to the strengths of your storage subsystem. It won't have any effect on your camera bandwidth. You're tuning your camera output to complement your storage. And in the iSCSI world, you create an iSCSI volume within this pool of space in that IPSAN appliance. And when you create that partition or that pool, it appears to your camera as a drive, drive D, drive E, drive F. So rather than creating one giant drive D and taking all of your cameras and writing all of the data to that one giant drive D, break it up. And the reason that you want to break it up is you get to take advantage of the different 1 gig ports. If you have one giant volume, it will only use a single gigabit port. But if you break it up into 2 volumes, it'll use 2 ports. If you break it up into 4 volumes and you have 2 ports, it's going to balance them 2 and 2 across those ports. So drive D data that comes in from these cameras runs down, runs through this port into the storage. Drive E can come through and into this port. The same. Now this one's going to use the second port out of the switch, to the second port into the NVR, to the second port on the switch in the SAN side, to the second port on the storage. The same with the light green path. It's going to come through, and essentially we've broken this thing in half so that we're using 2 pipes instead of 1 pipe on each side. The other nice thing is if you can add in more pipes to facilitate this side, you can add in, as you add in more NVRs, boy, that's a nice square, you'll have a pipe that you can run over here, and you can add a pipe that way into the unit. So as you add NVRs, you add pipes, you balance your load. But the main thing to consider and follow as a rule is break your cameras up into different drives and send the camera data to different drives so that you get more balanced performance, you get increased performance, and it makes an allowance. If you had one monolithic volume, it wouldn't use the other pipes. So you also get failover within the different NIC ports that are within the subsystem. And I wanted to end this session on an even number, and 10 today is my favorite even number. So are there any questions, any screens you'd like me to go back to review, anything else that I could answer at this time?
I did have one question come up. Will there be an instance where video cards will assist in the whole monitoring and/or recording?
There are instances where there's an aid, for instance, where the card itself, one of the latest ones is H.264 decoding, where they use the capability of the card to decode so they don't put a burden. H.264 is kind of special right now because MPEG, which is essentially the same data as DVD, they built in DVD or MPEG decoding into video cards a long time ago. So rather than the NVR taking the data stream or taking the data, decoding it, and sending it out in a format that the PC could take or the viewing station could take, that would consume cycles within the NVR. So what they're doing now is they're taking the data as H.264, nice and small and compact, sending it out to the viewing station, and the viewing station then is using the H.264 decoding capability to decode it and view it. Now the beauty of using a video card to decode is you're not using any CPU cycles. You're actually using the decoding hardware capability of the card to display. So there is that. There's some other people that have designed data to be pulled off of disk or taken from cameras and fed directly out, again with client software that does the work instead of the NVR. And the reason is the name of the game, primarily, foremost, of course, is to record as well and as fast as you can. So if you anytime you can compromise an NVR with client viewing going through it, client viewing responsibilities. You can burden it with analytics. You can burden it with management. Now, there's different reasons why different manufacturers do it, but an ideal situation is an NVR and storage sole intent in life is just to take data and record it. It's a pretty simple task. And the better you do that, it seems the better the entire subsystem.
Okay, I've got one more question here, and I'm just reading it right now. Does the DNF storage calculator on your website account for the rule of thumb percentages when RAID 5 and other parameters are selected?
No, it doesn't. It's asking for usable, it's presenting usable capacity. So you would have to accommodate that. We do have a RAID calculator available. I think it's also available in security if you want to comp for that. But no, it's presenting what it needs. There's a multitude. I mean, you could be RAID 5, you could be RAID 6. Your volumes could have to span expansion, shelves, and so forth. So that's why we didn't, get more complex than usable capacity. That's what you have me for, and Frank and Joe and Rupella.
Okay, I don't see any more questions coming up. If anybody has them, please feel free to send them through right now.
All righty, well, if nothing's coming, I thank you guys for attending. If you have extra questions, please route them through your rep, and we'll take care of you, or put them in the survey when you're signing off, and we'll get back with you guys as fast as possible. So I thank you for your morning or eating a little bit into your lunch. Bye-bye.